Welcome to the lecture 14 of the course CS213 Object Oriented Programming of the Cohort University of Science and Technology. In this lecture we will continue our discussion of polymorphism, and we will continue with the example that we were discussing the previous time in our lecture 13, and we will further look at some more concepts that are relevant to polymorphism. Again, the book that we are following for this course is Java How to Program Early Objects version, detail and detail, and there are some tutorials that you can follow on the links given on this slide, and maybe if you can follow other useful material online, and some of the relevant concepts that we have discussed previously, and maybe we discuss some of the others in the future classes, can also be seen here on this introductory slide. In our previous lecture we talked about an example where we had a person class, and then we had different kinds of chefs that were the subclasses of that person class, and we had a cook dinner method in that person class which was overridden by the subclasses of the person class, and we were calling the method of each of those subclass of the cook dinner method by using the objects of those subclasses. We were getting different kinds of results. What we can do here is that we can create an array of person objects, as we can see in this example, that if we create a list of the person objects or an array of the person objects, we can initialize the objects of the subclasses using a reference to the superclass. And the reason for that is that every object of the subclass is an object of the superclass. If we have an array of variables that refer to objects of many subclass types, and in this way we can initialize multiple subclass objects and store them in an array of the superclass. This example demonstrates that an object of a subclass can be treated as an object of its superclass, enabling various interesting manipulations. And we'll see in the examples in the future that we can use an object of the subclass as an object of the superclass, but we cannot use an object of the superclass as an object of the subclass. The reverse is not true. In the example below, we have an array holding 5 objects of type person. Because of their inheritance relationship with the person class, the house chef, the pizza chef, the KFC chef, and the takeaway chef classes can be assigned to the array. Within the for loop, as you can see, within the for loop, what should happen is the cook dinner method is invoked on each element of the array. And as we were doing previously, using the objects of each class separately, and we were calling the cook dinner method, same case will happen over here, that we are getting different kinds of results for each call to the cook dinner method based on the calling object. The result here depends on the object stored, not on the type of the variable. So it doesn't matter that the type of this variable is the person class, but the type of the object that the variable is storing, and that is what matters. For example, this plist0 is storing an object of the person class, so when we call the cook dinner method on this object, it should call the cook dinner method of the person class, and similarly this plist1 should call the method of the cook dinner method of the house chef class, and so on and so forth. So the result of this method call depends on the object stored, not on the type of the variable. And the reason for that is the object of the subclass is an object of the superclass, and we can hold the objects of the subclasses in a type of the person class, in the type of the superclass, which in this case is the person class. and all of this is possible because of the inheritance relationship. And when we said that an inheritance relationship is a relationship where a subclass is a superclass, and in this case a person is a person, of course, but a house chef is a person because a house chef is a subclass of the person class. Similarly, a pizza chef is a person because the pizza chef is a subclass of the person class. And the KFC chef is a person because KFC chef in our example is a subclass of the person class. Takeaway chef is a person, and because takeaway chef in our example is inheriting the person class, and because of this relationship we can store references to the objects of these classes in the superclasses object or variable, and it will work the same way as we were doing it separately. This for loop will one by one call the relevant methods using a call to the cook dinner method. The relevant method for each class will be called. With the help of the same example, we'll try to understand what are the things that are checked at the compile time and what are the details that are checked or executed at the runtime. So if we look at our example, what we did was we declared an array and we stored all of the subclass objects into that array that was an of type person. Now our compiler will make sure that if the variable or the array that we are storing an object in is compatible with the type of the object that we are storing in that array or that variable, and the compiler checks this at the compile time before the program is executed. When a superclass variable contains a reference to a subclass object and that reference is used to call a method, the subclass version of the method is called. And we saw that in our examples as well, that when we were using the superclass to make a reference to a subclass object, and when we call the method that were there both in the superclass and the subclasses, the subclasses version of the method was being called. For example, in the person class we had a cook dinner method, and when we declared an object of the, for example, one of the subclasses using the reference to the superclasses variable, and when we use that variable to call the cook dinner method, the subclasses method was being called, and we saw that in our previous examples in the previous lectures as well. What the Java compiler does is it allows this crossover because an object of a subclass is an object of its superclass, but not vice versa. The compiler will need to make sure that if we are trying to call a method that is not there in the superclass but that is there in the subclass, we cannot call the subclass's method using an object of the superclass or a reference to the object of the superclass. And this checking is done at compile time. When the compiler encounters a method call made through a variable, the compiler determines if the method can be called by checking the variable's class type. And it does that, it checks the compatibility of the two objects, if they are compatible. And they are compatible in the sense that if an object of the superclass is an object of the subclass, then that object is an object of the superclass as well. But that object can only call a method that is there in the subclass. If a method does not exist in the subclass, we cannot use the superclass reference to call that method in the subclass. And we'll see this in the examples as well. What happens is that when the compiler encounters a method call made through a variable, the compiler determines if the method can be called by checking the variable's class type. If that class contains the proper method declaration, first case, if there is that method, for example, we have a subclass and it has a method and we are using an object of the subclass, to call that method that will be executed as normal if the class contains the proper declaration, or in the second case if it inherits that method. If the method is not in the subclass, if the method does not exist, then check the superclass, because the object of the subclass is an object of the superclass that will be compiled. And that is what happens in our list or array of variables. When we create an array of variables, we are able to assign the subclasses objects to that array only because those objects belong to the superclass as well. Now let's look at what happens at the execution time. At the execution time, the type of the object to which the variable refers determines the actual method to use. We saw this in our earlier examples as well, that it only depended on the type of the object that we were using to call the method. The output of that method was completely dependent on the type of that object, and we'll explain this again. This process is called dynamic binding. The method is executed based on the object, not on the type of variable. And in our given example, what we did was we declared an array of type person. The type of the array was the person class, and that type was the same for all of the objects that we were using for a reference, and those reference were the subclasses of the person class. Now, even though the type of all of the objects was the same, each object was generating a different output from the method call. And this happens because the derived classes override the cooked dinner method of the person class. This makes the overridden cooked dinner methods of the derived classes execute when the cooked dinner method is called using the base class reference from the array. So let's say, for example, this plist, each of these variables has a data type or a type person, and each of these variables is referencing to a different kind of object. For example, plist0 is referencing to the person class's object, plist1 is referencing to the house chef class's objects, and when we use plist1 dot cook dinner, the house chef class's cook dinner method will be called. But when we use the plist0 dot cook dinner, the person class's cook dinner method will be called. This is all because of overriding that the cook dinner method is overridden by the derived classes, and it only depends on the calling object. So the first line, the plist0 will invoke the cook dinner method from the person class, and the plist1 will invoke the cook dinner method from the house chef class. It does not depend on the type of the variable, but it depends on the type of object that we are using to call that method. That the output will be relevant to whatever their implementation of the method is in that class. Now let's look at what we cannot do using polymorphism, what is not allowed by the compile and will possibly generate a compile time error when we try to do that. For example, the clean kitchen method, if you remember from our example, was only defined in the house chef class. And for example, there are two objects, one a subclass object with the subclass reference house chef, and another is a subclass object with a superclass reference. In this case, as we can see, that we are creating an object of the subclass house chef using a reference to the superclass person, and in this case we are creating an object for house chef using a reference to the house chef itself. Now we will see, and we saw in our previous videos and in this examples, that an object of the subclass is an object of the superclass, and we can use that object to call the methods that are combined in they are common in the two classes. So if we try to call this method, and both of these methods are being called with the subclasses object, for example W is a subclass object with a subclass reference, and this method is being called, and we understand that this cook dinner method should call the method of the house chef method. It will not call the method of the person class, but it should call the cook dinner method of the house chef class. But if we try to do this, P1 as we understand is a subclass object but with a superclass reference, and this should generate a compile time error. This one should execute correctly because the cook dinner method is defined in the house chef class, and if we call that method using an object of the subclass, even if it is referencing to the using a subclass reference, it will execute fine. The clean kitchen method is defined in the house chef class, and if we call this method using an object that is uses a reference of the subclass, again it will be executed. This method, the p1.cookDinner method, will be executed because this is a method that has been overridden from the superclass, and it exists in the subclass as well and the superclass as well. So this will call the subclass version of the method. But this fourth case, where we are using a method that is exclusively defined in the subclass. Now the superclass cannot have access to this subclass method that is not there in the superclass. We cannot do this in Java, and if we try to do this, we will get a compile error, and it will tell us that no clean kitchen method declared in person class. If we were to be able to call this method using the person class, using this subclass object with the reference to the person class, then we would need to define this method in the person class, and we would need to override that method. But that is not currently the case, and Java should not and will not allow us to do this. A superclass reference can be used to invoke only methods of the superclass. The subclass method implementations are invoked polymorphically. And that means that, understandably, a superclass reference can only be used to invoke only methods of the superclass. But if there are methods in the superclass that are overridden by the subclasses, then those methods can be invoked polymorphically. For example, if we change the calling object with the subclasses objects, then those methods can be called polymorphically, as we saw in the cook dinner case. Java decides which classes cook dinner method to call at execution time rather than at the compile time, and we saw that in our previous slides as well. Attempting to invoke a subclass only method directly on a superclass reference is a compilation error. So we need to keep this in mind, that a subclass is a superclass, or an object of the subclass is an object of the superclass, but the reverse is not true. The superclass object cannot access the subclass's method. Exclusive methods are not accessible in the subclass. It can only access the methods that are overridden by the subclass. Now let's look at a couple of examples to help us try to understand or check our understanding of the polymorphism concept or idea of polymorphism. Let's say we are given a class A, and there is another class B that extends class A. If we look at a class A, it has an instance variable X, then a constructor A, and then there is another constructor with 1 parameter. We have a constructor A with no parameters, but it initializes the variable to 100, and the second constructor initializes the variable to a value that is passed as an argument to this constructor. And there is then a toString method that should print the value of x when we print the object of class A. And we see that we are having declaring objects of these classes. Let's look at class B before we go into the printing details. Class B extends class A, so it should inherit the x variable x, and then it should have its own details as well. We'll see how these variables are initialized for both of these classes. So when class B extends class A, and we need to keep in mind the default constructor calls that we discussed in previous lectures. Class B has three constructors, one with no parameters, one with one parameter, second one, and a third one with two parameters. So we are using multiple constructors over here. And then there is a toString method that is trying to print the superclasses variables value x, then the value of x for class B, and the value of x for the value of y for class B. We'll try to see this. Now if we are creating an object of a1, if you can try and relate these outputs to the print statements. For example, if we are printing an A, what should be the output? We can try and match the outputs. And for example, if we are printing the object A2, what should be the output? And if we are trying to print, if we are printing B1, what should be the output? You have seen that whatever there is in the toString method, when we print that object, those details are printed as it is. So you can go through this exercise and try to match the outputs if they are correct or not. In this other exercise example, apparently we have some objects that might belong to an animal class or a pet class. So these are the subclasses of the pet class that we can see in this slide. What you have to guess is, for example, these are the objects, and each object has been initialized by reference to the class itself, so there is no reference to the superclass, and we are trying to print the output of a method polymorphically. They all share the same common method, speak method, and what we need to guess is what should be the output when we call this method on the objects separately. So the speak method is being called by the cat object, the dog object, the frog object, and the flamingo object. What should be the output of these method calls if you look at the structure of the classes and their relationships? If you want to if you want to include the implementation details or as any missing syntax, you can do that. For example, we have the pet class, and the pet class has a speak method which is printing a certain statement. Then that class is extended by the dog class, and the dog class inherits or overrides the speak method with some addition to that method. Similarly, the cat class overrides the speak method and also adds to that method, and the flamingo class extends the pet class and overrides the method with its own implementation. You can implement the frog class with whatever you want to get the output from the frog class, but it should have the speak method of its own that is overwritten from the pet class, and you can guess the outputs of these method calls. So that is the exercise that you can try. This will conclude our lecture 14, and we'll continue our discussion of polymorphism in the coming lectures.